Good morning, students. We already discussed equation of the tangent to the circle. Today we are going to discuss about equation of the normal to the circle. Now, what is the meaning of normal? It is a perpendicular line. See here, it is a tangent. We already discussed. This is to be point of contact x1, y1. Normal is a perpendicular line to the tangent at the point of contact. That is the important one. At the point of contact. Now listen. This is the tangent. This is the normal. This is to be normal. See, this is the general circle. This is to be tangent. We already discussed about equation of the tangent. Now we are going to discuss about equation of the normal. So normal is a straight line which is perpendicular to the tangent at the point of contact Px1, y1. Now listen, we already discussed the equation of the tangent with the help of this one. Y minus y1 is equal to m into x minus x1. This is to be equation of the tangent. We already used this one. Now, what is the formula to find equation of the normal? Listen, we can use this one. Y minus y1 equal to minus 1 by m of x minus x1. This is to be equation of the normal. We can use this formula. Y minus y1 equal to minus 1 by m of x minus x1. So, equation of the tangent, with the help of this equation, we already derived. Now, with the help of this equation of the normal, now we are going to work out. Now listen, we are going to work out the equation of the normal. So normal is a perpendicular line to the tangent at the point of contact. Now listen, equation of the normal. Today we are going to work out this theoretical concept. We already worked out the theoretical concept of equation of the chord. Then chord becomes tangent. How the chord becomes tangent? Already we explained. The point qx2, y2 moves towards px1, y1 and coincides with px1, y1. Then the chord becomes tangent at the point of contact. Now we are going to work out equation of the normal at the point p of x1, y1. Therefore, it is a perpendicular line. Normal is a perpendicular line to the tangent at the point of contact Px1, y1. Now I can use this formula. Equation of the normal is nothing but y minus y1 equal to minus 1 by m of x minus x1. See, here m is the slope. Here m is the slope. We already worked out the slope in the derivation of equation of the tangent. Just I can use here y minus y1. You can verify your previous video. The slope is nothing but minus of x1 plus x2 plus 2g divided by y1 plus y2 plus 2f. This is said to be equation of the normal. In this we are substituting the slope of x minus x1. Of x minus x1. See here, this is the slope. Already we worked out slope m equal to minus of x1 plus x2 plus 2g divided by y1 plus y2 plus 2f. Now we can take the reciprocal. Automatically negative will be removed. Therefore, y minus y1 is equal to, take the reciprocal, y1 plus y2 plus 2f. Again multiplication with the x minus x1 divided by here x1 plus x2 plus 2g. So take the reciprocal, negative will be removed. We can get y1 plus y2 plus 2f divided by x1 plus x2 plus 2g. Now we can cross multiply this one. Therefore, y minus y1 of x1 plus x2 plus 2g is equal to, in your RHS side, y1 plus y2 plus 2f. Again this is multiplication with x minus x1. In the derivation of equation of the tangent, we already substitute this value x2 equal to x1 and y2 equal to y1. Therefore, we can substitute the same data here. Substitute x2 equal to x1 and y2 equal to y1 in this above equation. Now substitute x2 equal to x1 and y2 equal to y1 in this equation. Now we are getting the equation of the normal with the help of y minus y1 equal to minus 1 by m of x minus x1. Substitute the slope m. Already we derived in the equation of the tangent. Take that slope, substitute, then take the reciprocal. After that cross multiplication, we can get this equation. In this above result, we are going to substitute x2 equal to x1. Now listen, y minus y1 of, see here, x1. Again one more x2 is here, again replace x1 plus 2g. In the same way RHS, y1 plus this y2 is replaced by y1, again plus 2f, again x minus x1. X minus x1. Here x1 again adding with x1, we can get to 2x1 already 2g. Therefore y minus y1 of 2x1 plus 2g is equal to here 2y1 plus 2f, then x minus x1. Take out 2 from this one, again take out 2 from this one, we can divide both sides, divided by 2. Now the above equation modified, y minus y1 of 2 will be removed, we can get x1 plus g is equal to here y1 plus f, 2 will be removed, take out 2, here also we can take out 2, it will be divided by 2. Then we can get x minus x1, x minus x1. Here see, the two brackets will be product each other, here the same, you can multiply the elements inside. Now this y1 is multiplication with the x1, yx1. Again y is multiplication with the g, we can get yg. Here y1 is multiplication with the x1, we can get x1 y1. Again in the second place minus g y1. See here, just a product the elements. Y is multiplication with the x1 yx1, again yg. The negative is multiplication here, minus of x1 y1, again negative g y1. In the same way, we can work out the multiplication in the RHS side. This y1 is multiplication with the x, we can get x y1. Again see here, minus of x1 y1. Again f is multiplication, we can get fx. Again multiplication with the fourth element, f x1. So this y1 f multiplication inside, we can get this element. In your LHS RHS compare, see here x1 y1 negative. In the same way here, x1 y1 negative, we can eliminate this one directly. What are the remaining elements? See yx1, then plus, see this one, yg minus gy1. So pair this one yg minus gy1. Convert in the same side. So minus xy1. Convert in the same side. Minus fx. Convert in the same side. Plus fx1 equal to 0. Listen this one. After the multiplication is over, x1 y1 in the same side, LHS and RHS, the same value, it will be removed. After that, yg and gy1 are g families. Convert these xy1 to the other side, we can get the negative. Here we can get minus fx negative. Negative becomes positive. From this, we are able to pairing the elements. We are able to pairing the elements. We can get the equation of the normal. See here, yx1, that is the positive. See here, minus xy1, yx1 minus xy1, pairing the first. Then take out this one, g as common first. From this g as the common, the remaining is y minus y1. Here take out f as common, then we can get f as common, we can get x1 as positive minus x as negative equal to 0. This is said to be equation of the normal. Or we can adjust like this. We can write this element like this: y x1 minus x y1 plus c, take out g as common, y minus y1. Here if you are taking negative f, it can be written like this: x minus x1 equal to 0. Both are same only. This is said to be equation of the normal. This is said to be equation of the normal. See, both are same only. Here I am taking negative, then it can be written in the form of minus of x minus x1. Once again listen, equation of the normal means use the formula y minus y1 is equal to minus 1 by m of x minus x1. That is the general equation of the normal. Here m is the slope. We already worked out the slope in the equation of the tangent. Just substitute and take the reciprocals, work out the cross multiplication. After working out the cross multiplication, listen the concept carefully. Substitute x2 equal to x1 and y2 equal to yn, because we are derived that equation from the chord. In that chord becomes tangent. When a chord becomes tangent, the point q x2 comma y2 coincides with px1 comma y. Coincidence means x2 equal to x1, y2 equal to y1. Therefore use that concept. After that, work out the multiplication. Then we can get this type of equation. This is to be equation of the normal. yx1 minus xy1 plus g of y minus y1 plus f of x1 minus x1 equal to 0. Or we can write like this. This is to be equation of the normal. So far we worked out three derivation part. Number one is equation of the chord. Number two, equation of the tangent. Now equation of the normal. Again we are having one more derivation part. That is the line y equal to mx plus c. Derive the condition for the line. Condition for the line y equal to mx plus c to be a tangent, to be a tangent to the circle x squared plus y squared equal to a squared. This is the another derivation part. Derive the condition for the line y equal to mx plus c to be a tangent to the circle x squared plus y squared. What is the meaning is, this is said to be a general circle. In the circle, center is said to be 0, 0. This is the center. Then the radius is said to be a. Then the equation of the circle is x squared plus y squared equal to a squared. Now a straight line. Consider y equal to mx plus c is a straight line. This straight line converted to be a tangent. This straight line y equal to, that is the condition. Condition for the line y equal to mx plus c to be a tangent. So if a line converted to be a tangent, then it must satisfy some condition. What are the condition? Okay, that is the derivations concept. Condition for the line y equal to mx plus c to be a tangent to the circle x squared plus y squared equal to a squared. Now, the given circle. What is the given circle? X squared plus y squared equal to a squared. See, this is equation number 1. Now, here given line is, one more line is given y equal to mx plus c. I can convert this y in the same side, so I can write like this: mx minus y plus c equal to 0. Say this is equation number 2. Now we already worked out equation of the tangent to the circle. What is the equation of the tangent? Equation of the tangent Equation of the tangent is, what is the formula already we worked out? X squared is replaced by xx1. Then y squared is replaced by yy1 equal to a squared. Convert into the same side. So we can write xx1 plus yy1 minus a squared equal to 0. This is the equation of the tangent. Equation of the tangent you can write like this at p of x1 comma y1. So equation of the tangent at p of x1 comma y1 is nothing but x squared is replaced by xx1, y squared is replaced by yy1 minus a squared equal to 0. This is the equation of the tangent. Now what is the required condition? This line converted to be a tangent. So we are going to derive that condition. So we have to derive a condition, this given line y equal to mx plus c to be a tangent. That means here from this concept, equation number 2, equation number 3, both represents the same line. Both represents about the tangent. Therefore, these two lines represents the same concept. We can say that like here equation 2 and 3. Here equation 2 and 3. Equation 2 it is a given line. Equation 3 it is a tangent. Both the line equation 2 and 3 represents the same line. Represents the same line. Same line means about the tangent. So equation 2 and 3 represents the same line means the coefficient of x and the coefficient of y and the constant term are in proportional. Both the lines, see here 2 and 3 represents the same. So they are going to represent about the same means equation 2 and 3 represents the same line. Therefore coefficient of x, that means you can write like this, coefficient of x comma coefficient of y and constant term are in proportional. Constant term are in proportional. Therefore coefficient of x comma coefficient of y and the constant term are in proportional. We are going to work out that proportionate. See here coefficient of x is m divided by, what is the coefficient of x here? x1. That is equal to, what is the coefficient of y here? minus 1. What is the coefficient of y here? y1. That is equal to, see the constant term. Here what is the constant term? Minus a square. So this is called proportionate of 2 and 3. Therefore equation 2 and 3 represents the same line. The coefficient of x comma y and the constant term are in proportional. We are working out the proportional. Now listen. So I can compare the first and the last. We can compare the first and the last, second and the last term. See here, m divided by x1. M divided by x1. See, I can write like this, minus c divided by a squared. I can write this last term as c divided by a squared. I want to find the value of x1. Therefore, take the reciprocal. I can write like this, x1 by m is equal to minus of a squared by c. So take the reciprocal. I need to find x1. x1 is equal to minus a squared m divided by c. This is the value of x1. So x1 equal to minus a squared m divided by c. In the same way, I am going to work out the second and the third. Minus 1 divided by y1 is equal to minus c divided by a squared. Cut the both negatives and take the reciprocal. Now I can write y1 is equal to here a squared by c. This is y1. So y1 equal to a squared by c, x1 equal to minus a squared m by c. Therefore, point x1 comma y1, point p of x1 comma y1 is equal to, pair the values of x1 and y1. Here minus a squared m by c comma a squared by c. This is to be the point p of x1 comma y1, because at the point of x1 comma y1. So we are going to work out already, we are worked out equation of the tangent at, I already draw a rough diagram. So tangent at p x1 comma y1. So we are working out the point p of x1 comma y1. This is called tangent. So we need the point x1 comma y1. Therefore we worked out the point p of x1 comma y1. From this diagram we are making a conclusion. The circle passing through the point x1 comma y1. Already we justified the equation of the circle. What is the equation of the circle? X squared plus y squared equal to a squared. That equation of the circle passing through the point x1 comma y1. Therefore equation of the circle we already worked out, x squared plus y squared equal to a squared. This circle must pass through the point p of x1 comma y1. Therefore we can write a conclusion. The circle passing through the point, the circle x squared plus y squared equal to a squared is passing through the point, passing through p of x1 comma y1. See this diagram, this is the equation of the circle, that is the diagram of the general equation of the circle is x squared plus y squared equal to a squared. Center is origin 0 comma 0. Now p of x1 comma y1 as the point, so that the circle passing through the point p of x1 comma y1. Any equation passing through a particular point, we can substitute it here. x1 squared plus y1 squared equal to a squared. We are already worked out the value of x1 comma y1. See here, x1 equal to minus a squared m by c. So substitute x1 and y1. So substitute x1 and y1. Now I can substitute the value of x1 and y1 in the above result. So see, x1 is minus a squared m by c the whole squared plus y1 is a squared by c the whole squared equal to a squared. Now we are going to simplify this one. We are going to simplify this one. A squared the whole squared is nothing but a power 4 plus m squared by c squared again plus a power 4 m squared by c squared. Here is also a power 4 by c squared equal to a squared. We can divide this equation by a squared. See here also a squared, here one a squared, here also one a squared. So we can divide by a squared. Therefore this equation can be written in the form of a squared m squared plus here one more a squared. Consider c squared as the common equal to 1 because a squared is divided by a squared, we can get 1. From the numerator we can take out, see this one, from the numerator we can take out a squared as the common. The remaining is m squared plus 1 equal to, convert this denominator to the other side, we can get c squared. Therefore it is the required condition c squared equal to a squared of 1 plus m squared. This is the required condition. So listen once again, the question is find the condition for the line y equal to mx plus c to be a tangent to the circle x squared plus y squared equal to a squared. We are selecting the circle with the center as the origin, radius as the a. Therefore x squared plus y squared equal to a squared is the general equation. That is the equation number 1. Y equal to mx plus c, that is the given line. Already they are giving the line y equal to mx plus c. So convert it to the same side. Then equation of the tangent. The question is condition for the line to be a tangent. So we need the tangent. What is the required equation of the tangent? X1 plus y1 equal to a squared. Convert that a squared into the same side. Say that is equation number 3. Now equation 2 and 3 represents the same line. What is the meaning of same line? Both discuss about the tangent. That is the given data. So we can say coefficient of x, coefficient of y and the constant term are in proportional. Therefore we are working out the proportional. That is divide the coefficient of x divided by another one. So then compare. we are able to work out the values of x1 and y1. Here x1, the value of x1, we need x1 and y1. Here the value of x1 is minus a squared m by c. Then the value of y1 is a squared by c. That is substitute x1 and y1. Then simplify, we can get the condition c squared equal to a squared of 1 plus m squared. From this we can write like this, c equal to plus or minus. When we are taking the square root, use the plus or minus. The square root of a squared becomes a, then root of 1 plus m squared. So this is the required condition, c equal to plus or minus a into square root of 1 plus m squared. We can use the both ideas. So from this condition, this is the required condition, y equal to mx plus c to be a tangent. We are worked out. From this, c is the required condition. From this, we are able to work out two sub-results. What are the two sub-results here? See here. So, the first sub-result is hereafter. Consider this line y equal to mx plus c to be a tangent. To be a tangent. So we already worked out this condition. So we worked out the value of c here. Therefore now we can say y equal to mx plus or minus, instead of this c use this one. Instead of c I can use plus or minus a of 1 plus m squared is also a tangent. Is also a tangent to the circle. Here m is the slope. Therefore in terms of slope, if you are going to work out in terms of slope, then we use this equation y equal to mx plus or minus a of square root of 1 plus m squared is also the equation of the tangent. We already worked out one tangent, that is x squared is replaced by x and y squared is replaced by y. That is also the tangent. Here also we derived one more tangent, y equal to mx plus or minus a of root of 1 plus m squared. When we are using this one in terms of slope, suppose slope is required, then slope is given, we are able to use. This is one sub-result. Then second sub-result is point of contact. Point of contact. What is the point of contact? x1 comma y1 is the point of contact. We already draw that diagram. P of x1 comma y1 is the point of contact. See here x1 comma y1 we already worked out. What is the value? Minus a squared m by c comma a squared by c. This is the point of contact we already worked out. Minus a squared m by c comma a squared by c is the point of contact. In this we can replace the value of this c. Therefore we can write in see here already plus or minus. Here one negative. So we can use this one like plus or minus a squared m divided by the value of c equal to a of root of 1 plus m squared. Comma. Here instead of c we are using plus or minus. I can write here a squared divided by a into root of 1 plus m squared. Here we can remove this a squared and a. Therefore, this is to be the point of contact is the point of contact. I can use this one plus or minus a will be removed. Therefore, am divided by root of 1 plus m squared. Again, comma plus or minus. Here a once again removed. A divided by root of 1 plus m squared. So this is to be point of contact. So this is the two derivation, two extra results, sub-results from the derivation. The number one is y equal to mx plus or minus a of 1 plus m squared is also the equation of the tangent. Number two is point of contact x1 comma y1 can be put in the form of minus a squared m by c a squared by c. Here we can replace the value of c. What is the value of c? Just now we worked out plus or minus a of 1 plus m squared. Again we can replace. This a squared and a will be removed. The remaining is am divided by root of 1 plus m squared. Here a divided by root of 1 plus m squared. This is the another part. That means the given question is derive the condition for the line y equal to mx plus c to be a tangent to the circle x squared plus y squared equal to a squared. From that we are able to derive two extra derivation part, two extra results. Now there are one more result we are having, that is two tangents can be drawn from any point to the circle x squared plus y squared equal to a squared or any circle. We already worked out in your lower standard, in your 10th standard, in your practical geometry, you already worked out. Two tangents can be drawn. See here. This is the circle. See, one point is outside. From this point, say this is P of x1, y. See this point. From this point we can draw one tangent. Here also we can draw one tangent. Say PT1, PT2. These are the two tangents. Tangent number 1, tangent number 2. So we already worked out in your practical geometry in your lower classes. See here, a point P is outside. From this point we can draw two tangents. That is the already we saw in your lower classes. Now we are going to derive this one. How we are able to derive equation of two tangents theoretically? Now listen. Just now we worked out a condition. From that condition, see, y equal to mx plus or minus a of root of 1 plus m squared is a tangent to the circle. Just now we worked out, where m is the slope. So point is not given, we can select this one only. So y equal to mx plus or minus a of root of 1 plus m squared is a tangent to the circle. Is the tangent to the circle. Now listen, I can take this one like this. Y minus mx equal to plus or minus a of square root of 1 plus m squared. 1 plus m squared. This equation passing through the point, this equation passing through a point P of x1, y1. Any equation passing through a particular point we can replace instead of x, y. Therefore, y1 minus mx1 is equal to plus or minus a of square root of 1 plus m squared. I wish to remove the square family. Therefore, I can take squaring both sides. See here, y1 minus mx1 the whole squared is equal to, when we are using the square, then we can eliminate the plus or minus. Here it will become a squared of 1 plus m squared. A squared of 1 plus m squared. Again listen. Two tangents that is the theoretical. Two tangents can be drawn from any point outside to the circle. That is the heading. So we already worked out in your lower classes. We are able to draw two tangents from any point outside to the circle. See, y equal to mx plus or minus a of root of 1 plus m squared is the equation of the tangent to the circle. Here m is the slope. Instead of x1, y1, at the point x1, y1, we can select this one x1 plus y1 equal to a squared. When we are selecting this equation, the point must be at the circle. That means equation of the tangent at x1, y1, we can select this one. Here not, the point is given. Therefore, we are not able to use this one. So instead of that, just now I derived y equal to mx plus or minus a into root of 1 plus m squared is the equation of the tangent. I can take like this, y minus mx equal to plus or minus. This equation passing through a particular point P of x1, y1. So substitute that one. Convert into the same side, then substitute the point x1, y1. To avoid the root family, squaring both sides, we can write y1 minus mx1 the whole squared equal to a squared of 1 plus m squared. Now we are able to expand this one. It is in the form of a minus b the whole squared. Expand this one, we can get y1 squared plus m squared x1 squared minus 2m x1 y1 equal to, multiply inside, we can get a squared, again multiply inside, we can get a squared m squared. Now convert everything into the same side. Now see, already we are having m squared x1 squared, then minus 2m x1 y1 m x1 y1. Then already we are having y1 squared. Convert it to the same side, we can get minus a squared minus of a squared m squared equal to 0. See here, both having the same m squared family. Therefore, I can take out m squared as a common constant. The remaining is x1 squared minus a squared. Here, 2m x1 y1. Then y1 squared minus a squared equal to 0. Now you can just verify this equation. See, m squared, again m, these are the constants. So m squared means it must be a quadratic equation in m. So see, it is a quadratic equation in m. If we are solving this equation, we can get two values of m. By solving this equation, we can get two values of m. Say m1 and m2. Say m1 and m2. What is the meaning of m1 and m2? Slope number 1, slope number 2. Two different slopes we can get. Therefore, with the help of two different slopes, we are able to draw two tangents. So that is the logic. We are able to work out. If we are solving this equation, we are able to get two values of m. Say m1 and m2. By using the two different values of m, we can draw two tangents. With the help of two slopes, we can draw two tangents. So that is the concept. We can draw two tangents. So that is the logic. So the heading is two tangents can be drawn from any point. That is the heading. So use the slope equation of the tangent in terms of slope. What is the formula? Y equal to mx plus or minus square root of a into square root of 1 plus m squared. In that equation, substitute the point x1 comma y1, convert the remaining elements into the same side, root family into the other one side, then avoiding the root, squaring both sides, we can get an equation, quadratic equation in m. That is the logic. See, m squared of this one, m again constant. So this must be a quadratic equation in m. If we are solving this equation, we can get two values of m, say m1 and m2. With the help of two slopes, we are able to draw two tangents. So dear students, today we have derived three important theoretical concepts. One is equation of the normal. The second one is condition for the line y equal to mx plus c to be a tangent to the circle. The third one is two tangents can be drawn from any point to the circle. So everyone must go through this video and work out the theoretical part importantly. The theoretical part are very important. So get what are the knowledge behind this. So everyone take the notes properly, verify your video. Thank you.